In this example, we're working with our product to sum formulas. So if you look on your identity sheet, we're talking about product to sum. This problem is currently written as a product of two trig functions. So here we have sine times sine, or cosine times cosine. Currently written as a product where we're multiplying, and we're rewriting it as a sum where we're going to be either adding or subtracting values. So, for example, here we have sine of 6 theta times the sine of 2 theta. So to rewrite this product as a sum, what we'll be doing, because it's sine times sine, we have our formula here for sine times sine. And so it's going to be equal to 1/2 times the cosine of, and we subtract the two angles that we have, minus cosine, and then we add the two angles. So for example, on this particular problem, as far as rewriting this as a sum, it's going to be 1/2 times the cosine of, and then we subtract the two angles, so 6 theta minus 2 theta. We take this minus the cosine of, and then we're going to add the two angles, 6 theta plus 2 theta. And this is just coming straight from our sheet here, where we have, here's the product, sine times sine, and so this is what we're converting that into. If it was cosine times cosine, we would use this formula, sine times cosine, cosine times sine. Pay attention to your angles. So we're just plugging the values in, and we're just rewriting what we have. Now I can add and subtract these angles, so our answer is going to be 1/2 times the cosine of 6 theta minus 2 theta would be 4 theta, minus the cosine of, and then when we add the two angles, we get 8 theta. And that would be our final answer. We're just rewriting this. And so next we're looking at, again, rewriting, and now we're talking about I'm currently adding these two, and we're going to rewrite it as a product. So now we're looking at our sum to product formulas. It's currently written as a sum, and we're going to rewrite it as a product. So for example, in this one we have cosine of 3 theta plus the cosine of 5 theta. So it's a cosine plus a cosine. So if I look here, sum to product formulas, we have cosine plus cosine. So here is what I'm going to use to rewrite this as a product. So in this case, we're going to have 2 times the cosine of, and now we take our 3, we're working with our two angles now, so we have a 3 theta plus 5 theta divided by 2 times the cosine of 3 theta minus 5 theta divided by 2. And so again, simplifying here, I can take a 3 theta plus 5 theta, that would be 8, and divide that by 2. So we have 2 cosine of 8 theta. And then over here we have 3 minus 5, so that's a negative 2 divided by 2. So 2 divided by 2 is 1, but remember that was a negative. So now we're saying it's a negative theta. Now remember, cosine is, if we look over here, remember your even and odd identities, the cosine of the opposite of an angle is equal to the cosine of the angle itself. So we can rewrite that as cosine of theta as part of simplifying this. So we have 2 times the cosine of 8 theta times the cosine of theta. And now we've rewritten this sum as a product. Next we're looking at our projectile motion formula given to us here. Now that is our horizontal distance in feet that this projectile is going to be launched. And we're measuring that horizontal distance across there as we launch it upward. We've worked with similar formulas before. Let's see, so we have 1/32 times our initial velocity, and that's measured in feet per second. Now we're squaring that initial velocity, and we have that times the sine of 2 theta. Now our angle theta, that is the angle with the horizon at which our projectile is being launched. So remember, we did stuff like this before where we talked about the potato gun. So let's say that our potato gun will shoot at 120 feet per second. 120 feet per second for that initial velocity. And we want to see if we can launch it an entire football field, which is 100 yards. Now that would be 300 feet. Remember that we're saying our horizontal distance is measured in feet. And we want to figure out at what angle do we need to launch our potato gun to be able to travel the entire football field based on this information. So as far as plugging in what we know, we have 300 for our R value. We have 1 over 32 times our initial velocity squared. Now we said our initial velocity is 120, and we're going to square that. And then we're taking that times the sine of 2 theta. And so we're solving for theta here. Now first thing I would do is I'd multiply, get rid of the fraction. So multiply both sides by 32. That gives us 9,600. We could square this at the same time. That's going to be 14,400 times the sine of 2 theta. Now if we use our calculator, I'm going to divide this over. Remember, you're solving for theta, so I'm going to divide this over and get a fraction. So I'm going to have that 9,600 divided by the 14,400, and we get 2/3. It's 0.6 repeating. And so 2/3 is equal to our sine of 2 theta. Anytime we're solving for an angle, we're going to need to do the inverse, so we'll do that at this point. So we're looking at the inverse sine of 2/3. And that gives us an angle of 41.8 degrees. So now we're saying, since we took the inverse of both sides, we're saying that our angle is 41.8 degrees, and that's equal to 2 theta. So now I'd multiply both sides by 1/2, which then gives me an angle for theta, or I can divide by 2. Our actual angle is about 21 degrees to shoot that potato gun.